Hey guys, welcome back to the fourth part of this tutorial where we were exploring Three.js, React-Three Fiber and React-Three-drei. In our last tutorial, what we achieved was, understanding how camera works, and we made it in such a way that you can move your mouse around, and the orbit controls that was controlling the perspective camera was moving around. In this video, in this part, we will explore lights and shadows and something very new that just got released today, the environment. How you can dynamically set environments. It's a latest feature of React-Three-drei, got released just today. It's March 3 when I'm recording. So let's start without much further ado. I am Sohel and let's get started. All right, so let's talk about a bit of a theory first, because well, with Three.js, everything has to do with calculations or simulations of real physical phenomenon, and light and shadow are no different. So let me take you to the drawing board where I was explaining stuff, and let's think about something very simple for a while, right? You have a source of light here. It could be a candle, a torch, a spotlight, headlights, anything. You have a light source here. Let's color this yellow just for easier understanding. This is yellow, and imagine this to be a light source. Now imagine another object. Let's take a blue colored ball in front of this object. Imagine the ball is fully blue colored. I'm not wasting time coloring the entire ball. And now let's imagine that there is a wall just behind the ball, and let's color the wall green. So this is a wall, right? Let's imagine this is the wall. So you have a light, in front of it is the ball, and behind the ball is a wall. Now when light strikes the ball, what you get on the wall is a shadow, right? We have all seen this phenomenon. The way that lights and shadows work in Three.js depends on the type of light that you are using. What do we mean by the type of light? We're going to see very soon. But just remember that not all sources of light can cast shadows. And most importantly, not all materials in the meshes that you use, say for example the mesh of this blue colored ball here, not all materials will reflect the light around in a certain manner. I'm going to show you what I mean, but that's what I want you to remember, that if you need a shadow, you need a surface that can accept a shadow, right? Because if this wall wasn't here in the first place, you wouldn't have seen a shadow, right? So you need the wall to be accepting shadows. The way Three.js works is that you also have to tell the light and the object that they can cast shadows, which is by default disabled. So you have to enable shadows before you say that, well, shadows can be shown. You have to tell Three.js that, and the way you do that is by passing a few props, and we're going to explore all of that. But let me just take you to the Three.js documentation for now, and let me just quickly give you a quick run over all the kinds of lights that we have in Three.js. Go to the documentation, and I'll search here light. We have lots of lights, but I'm going to just explain the most important ones. First up, we have the ambient light, and in our code, till date, we were working with ambient light, and I just said that leave this for now. We're going to explore this later. So the time has come. Let's explore what ambient light is. So as the documentation states, ambient, wait, did I not click? Yeah, there's the ambient light. What the ambient light is that it's a light that comes from everywhere. It has no single point of source. It comes from everywhere. Like if you go out in the day, and well, you could say that the light comes from the sun. So you do have a point. But if you look around, you will see that the light you see doesn't only come from the sun, it gets reflected from every object around you, and everything seems to be uniformly illuminated, right? That sort of a light is what's called an ambient light. It's important to know that an ambient light cannot cast a shadow. It says right here, so it cannot cast a shadow. That's because you have no single point. And if you have no single point, you cannot interpolate a shadow on the opposite side. So just remember them. We have an ambient light. All right, next, let's move to the next important. Let's move to directional light. Well, as the name says, directional light is a kind of light that has a direction. let's say you want the directional light to throw some light from left to right and uniformly. What I mean by that is that, say, if you take this point here, the light that comes out of it is going to be of this shape, right? It's a point, and so light's going to spread out in this manner, right? And you're going to have a shadow of the ball from here to here. This black zone is where you're going to have a shadow, this black zone, right? This is how light works. Well, it was true when, I mean, it would have been true if this light was a point light. You will find it a point light in Three.js. I'm talking about this one, point light. Point light works in this way. The source of light is a point. But what if you don't want a light source that behaves as if it's coming from a point? What if you want your light to behave as if it was coming from everywhere but from a certain direction? Like this. What if you wanted a light like this? It's not coming from a single point, right? It's not. But it does have a direction. It does have a vector, left to right. So it will, I think directional light doesn't also cast a shadow because there is no single point. But let's verify my theory. I never used directional light before personally, but I don't think it casts a shadow. Oh yeah, it can cast a shadow. That's interesting. Well, yeah, I mean, why won't it cast a shadow? It has a direction, right? It has a direction. Even if it doesn't have a point of origin, it will cast a shadow. True that. It will cast a parallel shadow just like the sun does. So I think the shadow would be here, the same size as the object, unlike point light where the shadow expanded. Correct. Yeah, that's what would happen. There's so many stuff to remember, even I keep forgetting. But that's why the documentation is there. You can just have a look at it. All right. We have the directional light. The hemisphere light is also a pretty interesting one. What the hemisphere light allows you to do is, say you want a source of light that has two colors and you want two different colors for two different hemispheres or portions of your model. Say this blue colored ball we have. This is the northern hemisphere. This is the southern hemisphere, right? Say you want to be this part of the ball to be colored with a different colored light and this part of the ball, the upper one, to be covered with a different colored light. Say you want something, a light source that resembles this. Why can I not select a different color? Oh, yeah. So let's say we want a light source that does this. Well, what we can do is use something called the hemisphere light. The hemisphere light allows us to basically throw two different colors on two different hemispheres of our object. This entire thing that is, it's a horrible diagram. I'm so sorry, guys. But this entire thing you see here, why can't I select any color? Oh yeah, I'm still in the black tone. So yeah, these two lights are actually one single light called the hemisphere light in Three.js. So you're going to see that hemisphere light if you go. And each of these documentations sometimes may have examples. If you come to this page and then say, for example, we want to see the example of a hemisphere light. So this is very useful. This documentation is very juicy. You're going to see examples and code everywhere. So come to this page, come study the different kinds of light that you have and work with them. Like this is a hemisphere light. So why is this a hemisphere light? Well, if you observe closely, we have, okay, so what's the status on this? We do have a shadow, so we know that we have a light, where hemisphere light, again, it cannot cast a shadow. It cannot. So the shadow you are seeing is from the directional light, and that is confirmed. But if you turn off the directional light, you see that you only have the hemisphere light, and that's why you have no shadows, even though you have light, because hemisphere light cannot cast a shadow. But if you turn on directional light, well, now you have a parallel shadow like we discussed a few minutes back. And hemisphere light, so let's disable directional light for now and let's focus on what hemisphere light really does. Observe the bird very closely. I hope now we can zoom in. Just pause the screen and I want you to, well, how would you pause the screen if you want to listen to my voice? I'm stupid. Just look at the bird animating right now, okay? See its wings. The upper part of the wings are dark. The lower part of the wing has a bit of light, right? I mean, see the color difference. The lower part is lighter, the upper part is darker. Do you see that? That's hemisphere light. You have two different colors. I don't see the code for this right here. Oh, okay. I can click here and see the code. Okay. So I think that's what they have done. The lower portion has a lighter light and the upper portion has a darker light. So that creates this really beautiful effect. And let's look at the code to see if they really did that in that manner. We have the code here. No, not this. What are they trying to do? Yeah, this is the code for the 3JS, and let's study the code. I mean, and this is the hemisphere light. We have the same two colors. They use the same two colors. That is really weird. Oh, but then they said it differently. I mean, why would you want that? I mean, when you initialize hemisphere light, you're gonna pass two colors as the parameters. One is what's called the ground color, that is the color of the light here on the ground on the southern hemisphere, also called they're calling that the ground color. So the ground color and the sky color. So you're gonna have two different colors. What's the point of setting a color here then modifying it just two lines below? I mean, you get the point, right? So they have white above and a little, I think it's darker, maybe? Whatever, you can explore the colors. They have basically two colors, and that's why you're seeing the bird with two different shades across it. Yeah. So we're going to play around with some lights right now before we jump to something called the environment, something that got released just today with a new version of react-three-drei. So I'll show that, but let's first play around with a bit of light right now. So our scene look like this, very bland, and I think we have just a single ambient light. So we're going to decrease the intensity of the ambient light just so that we can play around with other lights. But we are not going to remove the ambient light because well, I want my scene to have some sort of lighting, even though other lights don't reach there. It'll make sense very soon. So let's decrease the intensity. You'll see it becomes dark. Well, it is. It has become dark. And just ignore the background color for now. Let's remove the background color for now. I think that would be good because it gives the illusion that we have a light, but we don't. It's all dark. And let me just do that quickly from the CSS. I think it's in app CSS, is it? Yeah, we have the background color. Let's disable, unset, and refresh. What comes? I think the default body color for, I think it's white, is it? I mean, you get the point. I mean, when you initialize a blank HTML page, the background color you get is the background for this canvas that you are seeing, because that's not actually the background of the canvas, it's the background of the DOM. Let's see if I can find a way to disable it, because right now it gives the wrong impression. Maybe that's the default color of that the browser wants to give to the web page, even if it doesn't have a color. Maybe I may be wrong. Let's just set this to black. Let's be quick about it, and we're done. This is what our scene actually looks like, because our canvas doesn't have any light except the ambient light, which we just decreased the intensity of. So this is what we have. Let's now play around, start exploring stuff. Let's add, what can we add? Spotlight? Or we can add directional light. Let's add a directional light. So let's quickly open the documentation. Let's look at all the parameters you need to pass to our directional light. Can cast shadows. It takes two of these, a color and an intensity. But how do we set the direction? Well, let's explore a bit. Creates a new cast shadow. You're gonna see this property very soon, what it does. And we have a target once from its position, and we set the position. Correct. Let's work with it. It's just like any other light. So we have the ambient light here. Now let's work with directional light. As always, I'm going to comment this out a bit. And we're going to say directional light. And we're going to have arcs. Remember, you use the arcs prop to pass parameters directly to the constructor of directional light. So whatever you pass in that set, in that list you saw there, is going to be this. So we need a color and an intensity. We're going to do just that. What color do we need? Let's go with white. Let's just go with white. And observe that although they use a hex notation for the color, you can also pass in a string. Both works in Three.js. So you could either do this or you can do that. I prefer doing this because then I can use VS Code to just change any color if I wanted to. So we have this. Let's set the intensity to be a full-blown one. Now, it is important to understand that how you position a light determines what kind of shadows it can cast and where the shadow would cast. If you look at this drawing that I made earlier, let's remove these arrows and stuff so it becomes a bit clean. Now, it's a point light right here, but the principle remains the same. If the sphere happens to be at coordinates 0, 0, 0, the light has to be, say, along some negative x-axis, right? And the wall can be along the positive x-axis. And then, and only then, can you see the shadow here. I mean, you get the point, right? You can have to put the things into their correct places. And where you place the light determines how the shadow is cast. And also remember that the default vector for anything in Three.js, like I said, is 0, 0, 0. So right now, if I save this, the directional light will have a target of 0, 0, 0, which means it's throwing its light at 0, 0, 0, but its position will also be 0, 0, 0. So it's casting its lights what it is. So you are not going to see any light. So let's change that before saving. Let's set the position to be, and it's a vector. Again, the same way you do with a mesh, the same way you do with the light. And let's say I want it to be a negative 4. I want it to have an elevation of 1 along the y-axis, and the z, I don't want anything with it. And target, I'm not overriding it, so it is still looking at 0, 0, 0 like we want. We'll go ahead and about the shadows, let's leave the shadows for a while. Let's look at how it looks without a shadow. Save. Come back here. And now you can see that, let me just refresh the page. So this is, you're seeing this right in front of you right now, right? On your left is the directional light. And you see that where we placed our light, you're gonna see the dark region of this ball and the lighter region of the ball correspond to that light. It's as if the light is in front of this ball. You can just imagine it, right? Because that is where our light is at position -4, 1, 0. Let's make the light a bit more beautiful. How can we do that? Let's bring the light a little closer. It's just me playing around with the values. You can do your own stuff pretty much. I won't be wasting a lot of time with this. You guys get the point. You can just play around with the code. It now looks like the moon. Let's raise it a bit. This me just playing around. Yeah, I think this looks cool for now. Okay, so now it is almost realistic, but there's one thing missing. If you have a light, if you have a wall, you get a shadow, but there is no shadow to this ball, is it? The floor should have had the shadow. Where is the shadow? Well, like I said, shadows are disabled by default by Three.js, and that is done to save some performance, because shadows, calculating dynamic shadows, require some computational power. Gamers would know this, right? If you increase the shadow quality, well, then your performance drops. So what Three.js does is that it disables shadow altogether. Now you might argue, wait a minute, I do see some shadows here. How is it disabled? I see the left side of the ball is lighter than the right hand side. Well, the right hand side isn't darker because you have a shadow. The right hand side is darker because you have an ambient light that is illuminating everything. So the right hand side is actually illuminated by the ambient light. by an intensity of 0.25. What I mean is that if I happen to remove this light, this happens. There is no shadow. You are not seeing this part of the object. It's not a shadow. You can't see the object. That's different from a shadow, right? So this is what it looks like without an uniform ambient light. But then wait a minute. Then you will argue, well, why can I see the floor then? Shouldn't the floor be dark if there is no light? And it should only be illuminated by the directional light. So why is the floor uniformly illuminated? And you would be right. And you would be right because, well, let me just put back the ambient light in. And watch as this floor you see here. And this mesh standard material you see here, let's change the material right now. It's mesh fog material. Let's explore different kinds of material. I'll take the ambient light again. I'm just going to comment it out this time. I'm not going to delete it every... Yeah, so there is no ambient light. We change it from a standard material to a fog material. We save. We come back here and let's refresh the page. We have our ambient light. Oh, wait a minute. Yeah, we don't have our ambient light. We only have our floor. So why is the floor illuminated? Well, I think the answer to that is because we have our directional light that is uniformly illuminating this. And that's because the intensity of the directional light doesn't decay away. I think that's the issue. So the ball is light and dark because the front side of the ball obstructs the light from going to the back of the ball, just like you would have in real life. But the floor is flat. There is no obstruction, so it's uniformly illuminated. And you can confirm this by, if you make the directional light disappear, what happens? Now the entire scene is dark. Well, the entire scene is dark, but you get the point what I'm trying to say, right? Whenever you're trying stuff with lights, you gotta have to remember how light works in the real life, and you're gonna have to simulate that. But let's say you wanted a light that, okay, now the floor is brighter. And why is the floor brighter? Well, because you have two kinds of light here. Let's refresh. And yeah, we are back where we started. Now, let's say you don't want a directional light. You say you want to reveal only the part of the floor that is illuminated. So you won't use a directional light over there. You would use maybe point light. Point light decays with distance. So you could try that. Let's try that right now. Let's what the hell is this? Hey, just give me a moment. What the? I'm so sorry, guys. There was a spot on my screen and I thought, my monitor, what's happening? But then I saw it's a bug that looks like a dead pixel. Embarrassing. Let's get back. Let's get back. So we were exploring. So what if I replace the directional light here by, let's take point light. Point light decays with distance, just like, let's say, light from a candle. The farther you are, the intensity of the light decreases, right? So we have point light with a white color. I think the parameter is the same. We have the color of the light and the intensity of the light, and we have a position. Save. Go back. And now you see something different. The floor isn't uniformly illuminated. See the left-hand side of the floor? You see that it's lighted there, right? As if there is a light. You can't see the light, but you can see the effect it creates. Like, look at the floor. It's lighter on the left-hand side, darker on the right-hand side. You see that? That is what's caused by the point light. Let's try this time with spotlight. Spotlight is one of my favorite lights. It looks cool. It looks really cool. Just like a spotlight. You have different parameters and props that you can use to make this light look more realistic. Please go explore and look at the documentation. For example, if you want to make the spotlight better looking, I mean, right now it just looks very unrealistic because lights are not sharp, they are dull, right? The way you would do this is I would decrease the angle, I would decrease the I'll decrease the distance of it so it doesn't go all the way to the back. I'll maybe increase the penumbra. These are all, let me just show you. There's so much to talk about in light. It's going to be a bit long video. Where is spotlight? Yeah. Let me show you with an example of spotlight. And you're going to know about all these properties that I'm talking about. So this is a spotlight. This looks much more realistic than the one we have right now. That's because they have a couple of parameters preset. Intensity is, well, the intensity. Feel free to play with this. Distance is the distance from the source of the light to the maximum distance that the light would be visible. Decreasing the distance would be this. See this? Angle, well, the angle is how much the light spreads. Decrease it and the light is going to narrow down. Increase it and the light's going to widen up. Penumbra defines the the blur of the border. This looks much realistic. This, on the other hand, what we have right now, it looks like this and it's not at all realistic. So increase the penumbra. Like I was talking, you're going to have to play with these parameters to find out what goes well, right? So we have currently, what light should we go ahead with? Should we go ahead with the spotlight? Let's go ahead with the spotlight. I made my mind. Let's go ahead with the spotlight. So let's look at the constructor for the spotlight. What does it have? It has a color, it has an intensity, it has a distance. Distance, I'm going to decrease the distance a bit. I don't need it going all the way backwards. The distance is 2. I'm going to have an angle, and the angle is in radians. Okay. Default is 0, no limit for the distance. Yeah. But now we do have a distance. We need to say the angle. Let's say angle to radians, no more than 30 degrees. We'll play around with the value a bit. Then the penumbra, the default is 0, so no spread, but we do want it to spread. 0.4 might be a good value. And finally, decay. Let's not modify the decay. Save. And we see a very small light, and that's because the light doesn't spread a lot. We need to increase the distance of the light. So let's do that now. Let's the distance was this one, I think. Let's make it 5. Okay, let's make it a bit more, maybe 7. Let's increase the angle to be 45, and let's decrease the penumbra a bit, just a bit. This looks a bit more realistic, I suppose. Let's increase the penumbra a bit, and let's increase the intensity of the light a bit, so it looks more real. Yeah, this looks like something's shining a torch on it. Yeah, this looks great. This looks good. Yeah, okay. Yeah, now let's move on to shadows. So we don't have a shadow right now. We have a light, we have an object. So where's the shadow? It should have been on the floor. So where is the shadow? Well, like I said, shadows are disabled by default. You're going to have to enable that. So let's see where the shadow comes from. The light. So let's go to the light. This is our light that is supposed to cast a shadow. I'm going to change it. Spotlight. Okay. So we need this to cast a shadow. And like I said, shadow is disabled. Let's enable that now. So you're going to enable a prop called the cast shadow. It's a Boolean property that is set to false by default. Enable it by passing cast shadow prop. And what it will do is that it will set the shadow property of the spotlight to be true, which means this can now cast shadows. In other words, it means that if the spotlight falls on any object, it has the ability to cast shadows now. But if you save this, you won't see shadow. I saved it, there is no shadow. Well, that's because, now let's come to number 2. The object that is supposed to cast a shadow also needs this property to be set true, because we're not casting a shadow, right? The object needs to be also told that you can cast shadows, in fact. So the ball, we set this to, and where did you, yeah, cast shadow, and save, but you are still not going to see a shadow. You're still not going to see a shadow. Hold on. But that's because the light, well, it casts a shadow. The ball can cast a shadow. But can the floor receive a shadow? Did we enable the floor shadow? No, we didn't. So we're going to do that now. Yep, it's disabled by default. Like I said, you're gonna have to enable all of this. So the floor is not gonna cast a shadow, the floor is gonna receive the shadow. So there's a prop for that, receive shadow. But I don't think even this would work. Will it? Yeah, it doesn't. It doesn't work. And that is because you're gonna have to enable the shadows globally for them to even appear here. So let's work on it. How do you enable shadows globally? Well, you go to where we had the initial scene here in the canvas. And do we have shadows property here? Yeah, we do have the shadows property here. Let's see if I remember this correctly. And we don't see a yeah, we do see a shadow. Is it because of this property I passed, or did the page not refresh? I was correct. If you don't see your properties come up, refresh it, because the renderer cannot be, cannot be replaced by something called the hot module replacement. It's complicated. So just refresh the page if you don't see your properties reflected on the screen. Save it. And if you remember, the renderer is inside the canvas by default. You didn't have to pass a custom renderer, if you remember, right? So the renderer has to be told that you need to cast a shadow. You have to enable the shadows. That's why pass the shadows as true. When you do that, now you have a beautiful looking, very realistic shadow. You have the light in front, the shadow to the right, the object in the middle. This looks like just a real object. Well, now our scene looks much more realistic, right? We can look around, yeah, much better, much better. And now let's play around with what if I deleted the cast shadow property from the spotlight. You're not going to see a shadow. Refresh. Shadow's gone. Paste it back. Shadows here. That's because, like I said, you're going to have to enable the shadows from everywhere. The renderer and then the objects that cast or receive the shadows respectively. Now, for the final part of this tutorial, something got released today, and I'm going to show you the tweet first. You can skip a few seconds after this if you want to if you want to see me do it, but I'm just going to go through the tutorial. I mean, that tweet. I'm just documenting it for myself, at this point. This is me, by the way. It's my profile. If you want to follow me, just go ahead and do it. But what this got released just 2 hours ago. It's March 3 right now. And something got released by which you can create your own environment. What do I mean by environment is that environment is something that surrounds the scene. You can do that. And right now, you can create your own environments dynamically. I'm going to show how that means. I'm actually going to try this for the first time now. I'm very excited. So you can play with this example if you want. Just search for this tweet by this user if you want. Just do it. Or you can just find me and then see what I retweeted, and you're going to see this. So let's try it with now. Right now, we are on a blue colored floor. So let's make our walls bluish. Let's give it a bluish aura around it, right? The environment, I don't want this to look like you are suspended in a black space. I want it to be a little bit bluer. So let's do that. And this is me exploring, so I'm going to fumble around a bit. But you can't really learn from anything if you don't fumble around a bit. You're always going to have to add your own touch. So here's me playing with the environment. And I think I'm going to embarrass myself in front of all my audience, but whatever. Also, do remember you do need the updated version of react-three-drei because this wasn't available in the versions prior to this. So I had to update my package right now. You need at least version 8.12.0 of react-three-drei. If you do not have it, go ahead and just type yarn add react-three-drei back in your terminal, and it's going to upgrade the package to 8.12.0. You need this to be able to explore environments. If you don't have this, it won't work. So just remember that. And I'll type your environment. I should have autocorrect. I do have autocorrect from react-three-drei. I do have the environment from here. Yeah. And now let's think about it. What is an environment? An environment is, let's go to the drawing board to help us visualize. Create a new image. Yeah, do. And delete the previous one. Don't need that. Now, let's think what is environment. Well, we have a scene right here, right? Let's just take the floor. Forget about the ball for a while. We have the floor. So what is an environment? Well, let's choose a different color, but everything surrounding above to the left, everything is an environment. What surrounds the object? How you can create that with Three.js? Because you can't just say, well, cast a color into infinity. There is no infinity. So how we can manage things? But one of the smart ways you can do that, and game developers use this technique a lot, is that you create a sphere, very, very large sphere that has its center at 0, 0, 0. So you have a sphere, imagine a sphere all around you, and you are suspended inside the sphere. If you gave the sphere some color, wouldn't it look like you were suspended in a colored environment? If the sphere was red in color on the inside, wouldn't it look like you were suspended in a red colored environment? Well, it would. And this is how we can create environments. So we'll do that right now. There are many other ways of creating environments. You can use something called the cubic map. If you want, you can explore cubic map on your own. I'm going to keep this tutorial simple, so we're going to go with a sphere. But do feel free to explore cubic maps as well. It's very interesting, and Three.js is full of examples. Go explore it. But let's try a sphere geometry first. So we need a sphere, right? Now it's a mesh. A mesh needs a material, and a mesh needs geometry. So let's create a sphere geometry like we did last time. And the args, well, if I remember correctly, let's see if the autocomplete works. Okay, it does. So radius is going to be huge. Let's take 50. Width and height segments is going to be a bit large. Let's take 100 and 100. And I'm going to close this up. We have a sphere geometry already. Now we didn't need a material, but now think about this. Our sphere is so large that it goes out of range of any light we have. The spotlight we have currently is somewhere along here, and it's pointing here, right? So what's going to illuminate the sphere? How can we see the color of the sphere? Because there's no light falling on it. Well, a trick you can use is by using a different material altogether. If I go to Three.js documentation again, the material we'll be using is called a mesh basic material, and that is one of the materials that contradicts physics in the sense that you don't need a light to see it, and that's the only material that I think the only material that you don't need light to see with. Mesh basic material. This material is not affected by lights, but since it's not affected by lights, you can see it even if there's no light, but you're not gonna see shading on it. Like, look at this object. Does it even look like a 3D object? It doesn't, because it doesn't interact with light. So just remember that. But you're gonna see this object even if there is no light. So you can see the ambient light right here is set to black, yet you can see it. Ambient light, even if it's set to red, it's still not gonna change its color because it is unaffected by light. So we want something like that for our environment, at least for this one. So we're gonna have mesh basic material, and let's look at the constructor, what it needs. I think parameters as an object. Oh yeah, okay, this one. So we do need a color, and we just need a color. Okay, we just need a color. The color would be, and we need some bluish sort of color. So let's start with white, but I'm going to use VS Code to not change the color to something. This looks cool enough. Okay, so we have the mesh basic material to have a very light color surrounding our entire scene in a huge gigantic sphere. I'm gonna save, and this would probably not work, would it? Save, refresh, and it still doesn't work, and it has a ton of error. What the hell? It's trying to download images, could not load. Well, does it require that? Well, wait. Yeah, Now's the moment to embarrass myself. Yeah, splendid. Oh, I need to go to react-three-drei for that. React-three-drei. And let's look at the documentation for environment. What did I click? Environment. Okay. Why did you affect scene.background? Array of cube map files. This is what I was talking about, but when I meant you can create an environment with with a cube map. These files you would need to pass, but I think it's enabled by default, so it's trying to fetch, but it can't find, and so it's crashing. But what if we don't want this? What do we do? What to affect a scene.background? But if we pass a background prop, it doesn't say what each of these props does. Whether to affect scene.background. We want the background to be affected, but we don't want the pictures to be loaded by default. No, it still doesn't work. That is weird. The files, we can set a single, okay. Let's set the files to be null. To be a null. Will that work? Yeah, it is looking still for the files and it's crashing out. Let's go to that tweet and let's explore how he did it. Seems interesting. Very interesting, in fact. Let's go to the code sandbox and let's explore how this guy did it. I was looking at this and here's the environment. And all he does is he creates a mesh. It looks beautiful, by the way, doesn't it? But let's try to recreate what we were trying to recreate over there. We have environment, we have the background. It doesn't fail here this time. Why is that? Okay, they have a sphere geometry like I talked about, a very gigantic the sphere. You might say, well, it has a radius of 1. How is it gigantic? Because the scale is 100 here. What do you mean by scale? Scale is simply a number that you multiply your dimensions with. So a radius with 1 scaled up 100 times will have a radius, an actual radius of 100. You can do it either way. Yes, one of the many things I didn't pass is the side, but that's not quite it. Let's do away with the layer material. This layer material is from another package that you can use to create materials on your own. We don't need that. We'll use a mesh basic material like we were trying to do, and it would turn white. How is this thing working? And the color, let's set that to be what we said earlier. The color, what are we doing different that this works here but doesn't work over there? We have a color, and let's make this correct. It works here beautifully. It doesn't work here. Let's copy this code segment and let's study it. If they do stuff different than us. I am stupid. I didn't put this inside a mesh. This has to be inside a mesh. What the hell am I doing? It has to be in a mesh. Come on, man. Like I said, I'm embarrassing myself at this point. A mesh needs a geometry and a material. A geometry and material are not standalone. Embarrassing. I saved this, but you are still not gonna see the blue color here. I refresh. And it is still trying to load the images. So weird. Why? This doesn't load that. If we copy that, totally replace this, and we need to import 3. 3 comes directly from the 3JS. 3 is the actual 3JS library. Import as 3 from 3. This is the actual 3JS library. If we save that, how does this work? Why didn't mine work? How was that different? What the hell? That is funny as hell. How? Why did mine not work? But theirs do. Let's study. Environment, background, we do about gigantic mesh. A mesh, basic material. We're missing the side parameter. What the side parameter does, let me just talk to you about it first before progressing further, is that when you render out something, there are two sides to any given material. There's a front side, there's a back side. What 3 does is that it doesn't render both the side because it's gonna be a little performant. I mean, it's not gonna be a little more performant than if we just enabled one side. And that is what 3ds does by default. It enables the rendering of only one side, the front side. It disables the back side. But for a sphere like this, the front would actually be the top of the sphere, like the surface of the sphere, but we don't want that. We're inside the sphere. We have to look at the inside surface of the sphere, right? So we have to enable the rendering of the back side, not the front side. So the way we can do that is just by passing a side parameter like they did with the mesh basic material, or you get the side parameter is accepted by any material. So just feel free to do that. Import 3, and it's not there again. Import everything. And why am I using capital letters on 3? Well, that's a convention. People use that. All capital 3. Use whatever you like. I've seen people do this everywhere, so I'm taking the same time. But let's observe what more. The scale is missing, but that's fixable because we have a gigantic sphere. And that's it. So let's disable theirs now. And let's enable ours and see why is theirs fetching. Why is theirs not fetching pictures, but our is trying to fetch a cube map? What are we not doing? Now, how is this working? Just a few moments before it, I think I needed to pass the side because if we didn't have the side, it couldn't render it out. Yes, I think that's the reason. Is it? I'm gonna hit my head on the wall. Maybe we needed to refresh, but I was refreshing. I genuinely have no idea why it didn't work that time. Maybe I can go look at the video back. Maybe I did something wrong. Whatever. Refresh. And it looks quite beautiful. You have the surrounding blue light. And if you observe carefully, the color of the ball isn't white. It's kind of bluish, isn't it? Or am I seeing wrong? Let's try with a reddish color. Let's try with pink and see if it stays on the ball. And you see now the ball isn't white. It's red. It's pinkish because it is reflecting the color that is behind it, that is surrounding it, which is the environment. This is the new feature that got released from react-three-drei, and it's beautiful. It's so easy to use this, but it looks so damn beautiful. But one note. The ball we are using has mesh standard material. Remember, how light interacts with the surface depends upon the kind of material we have. Mesh standard material simulates real life surfaces, so you're gonna see light bounce off it. What if we use something else? What if we use mesh form material like we did with the floor? Would it still give off this color? Let's try. And it doesn't. Because a mesh form material is not built to simulate an actual source of material. It doesn't. Replace this by a mesh standard material because this material can itself reflect light. With a mesh form material, you would have needed to specify its own, I think it's called emissive property. Emissive is a prop that you can just pass, and the color you set to the emissive property becomes the color of the object that it spreads the light with. I mean, what the hell am I even talking about? Like if you did something like a mesh Phong material, and you came here and set emissive. What you do with emissive is that you set a custom color here and the object would glow with that color, like you would do like in this example. If the surrounding was pink, the object would radiate pink. Before we had to pass the color pink like this, and then we would have gotten that effect. But now with this latest update, all you have to do is pass a mesh standard material and it takes a color from its surrounding. It's beautiful how they did this. It's beautiful. I'm gonna change the color back to, I don't know, blue. Was it? Yeah. Looks fantastic. Why am I getting, but looking at the picture of a ball, whatever. It looks great as of now. So we have lights, we have shadows, we have a beautiful surrounding. Look at this example if you need to figure stuff out on your own. I'm just going to show you one last thing before we conclude this. Is that our ball right here looks very bland. It doesn't look like it has anything much. Mesh standard material on let's make the floor mesh standard material as well. Let's see if that changes stuff. And it does, because now our surroundings is also reflecting the light on the floor. It's beautiful, man. It's really beautiful. I'm gonna go with this. What I'm going to do is increase the floor distance. So I'm going to make this 20. I'm going to make this 20 so you don't see the boundaries of the floor. I think this looks cool compared to what we had before. I mean, this really changes the game a lot. I no longer have to think about custom coloring of the floor. The surroundings can do that for me. It's beautiful. I am fanboying over shadows and lights. Yes, that's my life. Okay, but one last thing I'm going to show you is that a property, it's not really relating to light, but somehow depends on it. Like I said, mesh standard material can simulate real life objects and how the light reflects from it. So there's a property called roughness and there's a property called, I think it's called metallicness. If you increase the metalness, not metallicness, metalness, my bad. If you increase this property, it's gonna look like a metal. It's gonna shine. I'm showing you what I mean. Right now it looks very dull, right? The metalness is by default 0. You see this. If I make this 1, it's gonna be squeaky. It's gonna be bright. It's gonna reflect light like a piece of metal does. See what I mean? Save. See this? It's not behaving like a metal and not much like a rough surface. Let's decrease the roughness by, roughness is by default 1. We're going to decrease this to very, say 0.1. We're also going to decrease the metalness to be 0.9. Save. And this behaves like a metal now. See that? That's part of light you see. Well, that's how metals reflect light, right? Like a mirror. It sort of does it like a mirror. So we have this. It looks really cool for some reason. But I'm going to decrease the metalness a bit. I'm going to increase the roughness a bit. You play around with the values, see what fits good for you. I think I'm going to go with this. It looks beautiful. And yeah, so that's, but this wasn't possible if you didn't use mesh standard material. If you use, let's say a mesh, mesh Phong material, you don't have the metalness property. You don't have this property there. If you save it, it's not going to make a difference. It's not going to reflect light. It's not going to shine. So if you want a realistic surface, make sure to use mesh standard material. Do your own research and then figure out what works the best for you. But yeah, let's conclude the tutorial here. It's been a really long tutorial, but it was fun. I tried out this environment for the first time and it's awesome. I can't wait to just release this video on YouTube. But yeah, if you like this video, please leave comments telling me if this helped you or if I could have done something better, or better yet, just connect with me on Twitter. I'm very active over there and I would love to talk to you guys. So see you in the next video. Stay tuned.